Lesson 1.5, Equations. Please notice the difference between an algebraic expression and an equation. An algebraic expression, an example of one is 3x plus 7. An example of an equation is 3x plus 7 equals 13. An equation will always contain an equal sign. When solving an equation, you are finding a value for a variable that makes the expression or equation true. So that's what it means to solve an equation. You're finding a value for a variable that makes the expression or equation true. The replacement value is called the solution. The replacement set is a set of numbers from which replacements for a variable may be chosen. A set is a collection of objects or numbers shown in braces. Each object or number in a set is called an element of the set. A solution set is a set of elements from the replacement set that makes an open sentence true. Pause the video and take a moment to write down those definitions. Okay, let's look at example 1. It says this: find the solution set for each equation if the replacement set is 0, 1, 2, 3. And here's the problem. Number 1, 8m minus 7 equals 17. So what we want to do is we want to test each member or each element in the replacement set to see which one would be a solution set. So notice that here you're substituting 0, the first element, in our replacement set, the first element. We're going to substitute it for m and test it. 8 times 0 minus 7 equals 17. Is that true? Well, 8 times 0 is 0, minus 7 is negative 7. Does negative 7 equal 17? Negative 7 does not equal 17. Therefore, 0 is not a solution set. Okay? All right, so next we will test the second element in our solution set, and we will substitute 1 for m. 8 times 1 minus 7 equals 17. Well, let's see. 8 times 1 is 8. 8 minus 7 equals 17. 8 minus 7 is 1. 1 does not equal 17. Therefore, 1 is not a solution either. All right, so let's continue. So let's go ahead and substitute 2 for m and see if that's the solution. 8 times 2 minus 7 is 17. 8 times 2 is 16. 16 minus 7 is 17. Well, 16 minus 7 is 9. 9 is equal to 17? No, it's not. Therefore, 9 is not a solution either. So we're going to just check the last one and see if that is our solution. 8 times 3, we'll substitute it for m. 8 times 3 minus 7 is 17. Well, 8 times 3 is 24. 24 minus 7 is 17. 24 minus 7 is 17. And 17 does equal 17. Therefore, it is true. So the solution set is 3. And notice that 3 is written in brackets because it is a solution set. Okay, let's try number 2. And we'll do it the same way, but I'm going to work it out with you. Okay, so 28 equals 4 times 1 plus 3d, and if the replacement set is 0, 1, 2, and 3. Okay, so let's start with 0. So what we're going to do is we're going to substitute 0 for d. Okay, so 28 equals 4 times 1 plus 3 times 0. So what that means is that 28 equals 4 times 3 times 0 is 0, 1 plus 0 is 1. 28 equals 4. Does 28 equal 4? The answer is no. Therefore, 0 is not in our replacements, in our solution set. Okay. All right, let's try the next one. So this is not it. Let's try 1. 28 equals 4 times 1 plus 3 times 1. Okay, so we're going to work in the order of operations. Let's do 3 times 1 is 3. And 1 plus 3 is 4. So 28 equals 4 times 4. 4 times 4 is 16. Does 28 equal 16? No, that's false. So 1 is not a solution set. Okay, let's continue. We'll try 2 now, and I'll do these down here. 28 equals 4 times 1 plus 3 times 2. Okay, again, we're going to follow order of operations. So 28 equals 4 times. 3 times 2 is 6. 1 plus 6 is 7. 28 equals 4 times 7. 4 times 7 is 28. 28 equals 28. The answer is true. Therefore, 2 is the solution set for this answer. So the solution set is 2. Okay. All right. Now, there's not always, it's always not that clear cut when we are solving an equation. So let's take a look when we're finding a solution to an equation if we're not given a solution set. Let's look at this example. Number 3. We'll number this. Example number 3. 18 plus 4 in parentheses plus m equal to 5 minus 3 in parentheses times m. So go ahead and use order of operations. 18 plus 4 is 22 plus m is equal to 5 minus 3 times m. And now let's do 5 minus 3. It says 22 plus m is equal to 2m. And so what we can say is that the only value for m that makes this equation true is 22. So this equation, has one solution, and that solution is 22. It has one solution. Okay. If I'm going too fast, pause the video in between and catch up with me. Okay, let's go on to number 4. Copy down the problem. N, open parentheses, 3 plus 2, close parentheses, plus 6 equals 5n plus, open parentheses, 10 minus 3, close parentheses. Okay, the first thing we'll do is we will work with, in the parentheses, 3 plus 2 is 5. And again, 10 minus 3 is 7. So we're here. N times 5 is 5n, plus 6 is equal to 5n plus 7. 5n plus 6 is equal to 5n plus 7. When you see something like that, you can just say that it doesn't matter what you substitute for n on the left side of the equation, it'll never be equal to the right side. Therefore, sometimes our equations can have no solution. Okay, and then we have example number 5, the last possibility. An equation that is true for every variable, every value of a variable is called an identity. So write this one down. 2 times 5 minus 8, all in parentheses, times 3h plus 6 is equal to, open brackets, open parentheses, 2h plus h plus 6, close the brackets, times 2. So we go simplifying. We're going to simplify everything that we can. First by using order of operations within parentheses, within grouping symbols, until we get to the place where we're ready to use distributive property. Distribute that 2. And so at the end, here's what we come up with. We come up with an equation that reads this. 6h plus 12 equals 6h plus 12. Well, no matter what value is substituted for h on the left, it's always going to be equal to the right. This equation is always going to be true. So the solution here is any real number. Okay, let's practice these. Pause the video if you have to catch up and write down this problem step by step, understanding what each step is doing. Okay, and I'm going to go ahead and move on now to our examples that I'll work out with you. Here we go. Number 1. Please write it down. 7 minus, and then in parentheses, 4 squared minus 10, close parentheses, plus n is equal to 10. Okay, so our first step is to work within the parentheses, evaluating the powers. So here's what I'm going to bring down. 7 minus 4 squared is 16, minus 10 plus n is equal to 10. Okay, next I need to take care of the subtraction that's within the parentheses. So I'm going to do 7 minus 16 minus 10 is 6, plus n is equal to 10. 7 minus 6 is 1, plus n is equal to 10. And so because 1 plus n is equal to 10, we know that n is equal to 9. There's only one unique solution for n in this case. Okay, let's look at number 2. N, open parentheses, 3 plus 2, close parentheses, plus 6 equals 5n plus, open parentheses, 10 minus 3, close parentheses. All right, let's work at doing the parentheses. N times 3 plus 2 is 5, plus 6 is equal to 5n, plus 10 minus 3 is 7. Now, this commutative property can be written and should be written as 5n plus 6 is equal to 5n plus 7. And so 5n plus 6 equals 5n plus 7. Here we have no solution. There is no value for n that will make this equation true. Okay? Now let's move on to number 3. 12 times, open parentheses, 10 minus 7 plus 9g equals g times, open parentheses, 2 squared plus 5, close parentheses, plus 36. Let's work on the operations within parentheses, simplify as much as we can, and see what we have here, okay? So here I have 12 times 10 minus 7 would be 3, plus 9g is equal to g times 2 squared is 4, plus 5, plus 36. Okay, let's continue. 12 plus 3 is 36, plus 9g is equal to g times 9 plus 36. Now let's write both of these in the correct form. We said that variable terms go first. They go in alphabetical order and descending exponents. So I need to switch the order of these. 9g plus 36 is equal to, we know that g times 9 is 9g plus 36. So notice with me that 9g plus 36 equals 9g plus 36. No matter what number I substitute for g, any number, all numbers, will make this a correct statement. So my solution here is all real numbers. Okay? All right, so I have some practice problems that I want you to do. Notice for this, I want you to do 2, 5, 14, and 16. For 2 and 5, you have a replacement set that's given, so you have to test each value to see which one makes the equation true. For x, I have those highlighted, and for y, you have those that I've highlighted. Okay, and then for solve each equation, you're going to do 14 and 16. Okay, remember to identify any questions that you might have. Please be sure that you're ready for a pop quiz if possible. We may do that tomorrow. If not, we're definitely going to continue to practice this skill. God bless you. Have a great night.